All right, thank you. Welcome all the panelists. Please take a seat. Okay, this morning, I think we are waiting for people to wave in from their lunch. So this morning, Lina set the standard very high. So I need to make the standard even higher for the hardware panelist discussion. So this is Mark Tseng. I am from Samsung DRAM Product Marketing. I am representing NATEA in 北美台湾工程师协会. I would like to thank you, NATEA's team member, TTS sponsor, and all the volunteers making this happen possible. So we know in the last 2 quarters is a very special time in the hardware time. NVIDIA make into a 1 trillion market cap, and we know that is and the market start to realize the hardware is not like before. Previously, people all talking about software, but now it's about hardware. And this new hardware was invented by NVIDIA, enabled this whole new technology. And today we have all the technology leadership from a different sector. We have from ODM, OEM, SuperMicro. We have SoC IP, SiFive. We also have AI inferencing IP at the edge from Expedera. So I'm very happy to, I'm very excited to have this opportunity moderate today's hardware forum. So let me have a quick introduction about our team. So we have Mory Lin from SuperMicro. He's a VP of IoT, embedded and edge computing. And no further introduction needed. We know SuperMicro is under the spotlight with NVIDIA. So if every time Jason mentioned SuperMicro, they make $1,000, they probably make a few $1 million already. We have Jack Kang from SiFive. He's a senior VP of corporate marketing, BD, and customer experience. We have William Kou. He's a VP of sales from Expedera. And Expedera is an AI inference IP company leading the development in the edge low-power automobile IP solution. So let's give all our panelists a warm welcome, and we'll kick off today's forum discussion. Okay. So the first question, I will go. We know SuperMicro and make this amazing hardware with NVIDIA. And now, like this morning, in the keynote Wally mentioned, we are seeing the wave of GPU computing in the data center coming to the edge. I want to ask Mory, what do you think, what is impacting what happened of the edge computing of AI hardware?
Thank you, Mark. And I think this is a very good chance for SuperMicro to comment on this edge computing related to the AI topics. But before answering these questions, I think edge computing has been addressed the importance in the market for a while. And suddenly AI from the cloud become possibilities for the ChatGPT type of applications. And then they start to think about what about the edge? Have the same level of the innovation with the intelligence behind. And to reach this level, edge AI requires certain of the things. First of all, this machine or this service have to closer to the devices or to the people who are using those services. And to make this edge computing plus the AI, we require lots of effort behind. We are just one of the infrastructures under here to supporting all the application on the top. I think later on you can hear from William, also from Jack about this case. And to us, we think edge AI will bring wider possibilities and all the computing workloads back to the data center. So that's the reason why in this spectrum here, from the cloud down to the edge computings, all have a chance cross with the AI features inside. And this is a concept, but we also put it into the hardware. And you can recognize this morning, we put the AI in the data center. It's a bit different computing hardware. To the edge, there is a location challenge for mounting machines. And there is a thermal challenge like others is in the factories or retail space. The thermal will be also the challenge as well. So we have to have a different setup to make the performance could be secured at the edge. So from our perspective, I think the edge AI will have the same importance to the end user, but require different design know-how. So we definitely want to make sure that both spectrums, like the data center at the edge, can have the same flexibilities to drive AI power inside. Thank you.
Okay, thank you, Mory. Thank you for the insight. And then we are definitely seeing that edge computing, and then they have a booth outside. So if you're interested on their solution, you can also stop in by the booth or see from their website. Okay, with SuperMicro, they build the foundation of all the AI infrastructure. Then we were able to enable more application. And one of the key is all those IP companies. They make the design possible and bridge to the software. So we have a Jack. So I want to ask the Jack about the questions is, how do you see how the advancement in the AI algorithm, this time we see large language model, how does that affecting the hardware requirement from your perspective?
Yeah, thank you. And first, I want to thank everybody for coming and attending and hearing us talk. It's a Saturday, so spending your Saturday. I was surprised at the number of people here in total. My name is Jack. I work for SiFive. So we provide RISC-V IP. So we're kind of at the other end of the hardware spectrum in terms of, we're providing the components, the IP component, the design that goes into the silicon that ultimately makes it into a system that then gets deployed by folks like SuperMicro. So to answer your question about, I think the main thing that I think everybody has to realize about what we call AI, AI is this very kind of nebulous technology. It's evolving very, very quickly. And what worked yesterday is not what's going to work tomorrow because we don't know what's actually going to work tomorrow. If we were here a year ago, last year, everybody would probably be talking about neural nets and CNNs and how that enables all sorts of things. This year, nobody talks about that. Everybody's talking about transformers and how do you accelerate that. So will we be talking about transformers next year, or will we be talking about something else next year? I think we will see. Right, transformers is very exciting because it's they found in my opinion, they found a killer application, called generative AI, or I guess chat AI, ChatGPT. That's which uses transformers. So everybody's now chasing that. So from a hardware perspective, what that means to me is that the algorithms are going to continue to keep changing and evolving because we're not set yet. We don't know what the solution is. So how do you accelerate something that keeps changing? Because fundamentally, when you accelerate something, you take the algorithm, the software algorithm, and you're mapping it into hardware that can run it very fast and efficient. Because if you didn't know what it was, you would just run general purpose CPU, right? That's how we do in the last 40 years, right? So you accelerate because you know what the hardware requirements are, but the hardware requirements keep changing. So I think what that means from the hardware provider's perspective is understanding what parts can be accelerated, but more importantly, making sure that your solution is programmable. And I think the programmability gives the flexibility that then you can adapt to the changing algorithms without sacrificing too much of the hardwire acceleration. And maybe later we'll talk more about how RISC-V does that and how SiFive does that. But I think I would as everybody listens to us speak, I think I would keep that in mind. Like, what does it mean to be programmable? What does it mean to be adaptable? And the kind of last point is, I think this is why, in my opinion, why NVIDIA has done so well, because they have the best programmable engine that exists right now. It's called CUDA, program with CUDA. It's a programmable engine, and that's why it's been adopted so quickly.
Thank you, Jack. And we have when now we see like what Jack pointed out, all the different algorithm was making that infrastructure more demanding than before. In not only in a data center, also coming to the edge. And from Williams, their company Expedera, they are trying to enable this even in a lower power system. So I want to ask Williams, from their expertise, is how do you see the advance of the AI specific semiconductor that we are seeing today, the inferencing the bigger, broader scope of the AI design?
Thank you, Mark. Well, first of all, I too want to thank all of you. I know TTS provide a lot of very authentic Taiwanese food up and down this building, but thank you for taking time to come here and listening to join us. So, AI specific, right? So, plenty have been said and written about the general purpose CPUs and GPUs from NVIDIA, right? And with their CUDA being the de facto software standard and Mellanox being the top-notch switching solution to move data, we can understand, why they are doing so well. But outside of that, the general purpose CPU and GPU, there are plenty of companies, big and small, such as my colleague Jack here. They are dedicated themselves to AI-specific semiconductor or silicon IP solutions. So we can look at two different parts of the AI marketplace, right? The training and the inferencing, right? So in the training space, of course, a lot of training is being done in the cloud. A lot of cloud computing players like the Google, the Amazon here in the US, to the Alibaba and others in China, of course, they are using NVIDIA, solutions, as we all know. But they also, each one of them are developing their own ASIC, not only to reduce unit costs, but also they truly have unique problems and applications they want to have specific hardware to address, right? So those are internal solutions to those big companies. Outside of that, you have companies like SambaNova, Cerebras, Grok. They are developing, chips or even subsystems to address training related AI applications. And in addition to those, you have optoelectronic companies like Lightelligent, right? And even FPGA, right? Not too many people know that in the AI space depends on the training space, depends on the configuration. FPGA can be a pretty good solution there as well. So that's not just the big companies like Xilinx, but the newcomers like Achronix, right? So that's in the training space. In the inferencing, in the inference world, it gets even more diverse, right? So as you push further and further out to the edge, right? So it's all about the trade-offs of PPA in power performance area, right? And latency and bandwidth. So, you think about the requirements and the neural network models that's needed for a Bluetooth headset. That set of requirements will be vastly different than what you would see in the autonomous vehicle. So there are plenty of companies that's again developing chips and IPs, trying to address different niche market and application. So yeah, collectively there are plethora of different companies, coming up with AI specific solutions so that together we can advance AI from cloud all the way to the devices that's in your pocket.
Thank you, William. That's very insightful. So now we can see order for a different hardware to make some solution like NVIDIA happen. Now today we see in the data center is coming even more closely to our edge computing or daily computing that in your phone, in our PC. Now we want to ask a little bit more deeply question, which is for Mory. So this is actually amazingly, we know for each server they build is a huge, they have a lot of GPU, 4, even 8. Amazing power they can deliver, and then they can computing power, also the power they consumed. I wondering, how can you share with us what kind of innovation SuperMicro is working to even better for that thermal power management of a GPU?
This is a very very challenging questions, but I think it's good to share since we all are in the same rooms to try to make the AI, not just at the edge, also possible innovations in the data centers. And probably I will use a certain examples to explain why this topic is so challenging to all of us who are building the AI solution hardware right now. In the past, when you build a server, most of the server have the components such as the CPU, memory, hard drive, and with one card, like William mentioned about FPGA card. Those things all together in one system probably create a power consumption requirement like 1,000 to 2,000 watt without GPU. There was the age, many years is you using lots of devices. This morning, we present certain GPU. Those are the public information. And some of the GPU easily consume like the 300 watt per card. And then so easily you can calculate if there's a machine can support up to 10 GPU. So you need to have 3,000 watt just for GPU. And then if next steps, they are going to push the limit to a higher power consumption per card, then it's not about providing the bigger power supply only. Actually, you have to think about what about the heat? How can we bring out of it? And then we recognize this become much challenge by just using the air cooling, and which is also the public information we are doing right now. We have investments on the liquid cooling. So for sure, not put the liquid on the machines. It will be a big issue. And you need to have a technology to bring the heat or dispatches outside of the server from the data center to the other devices to cool it down and through the specific materials. And this will be the trend. Imagine if AI, it's very demanded for more computing power, and we need to have a very power efficient architectures, and plus with very efficient thermal solutions to do it. And this requires lots of know-how. It's no longer making a server AI computing faster and faster. We also make sure they can save the energies. Otherwise, you will bring another cost factors to all those people want to deliver the AI to the world. And so that was a very main topics we care about. And second thing is that we also care about age. So after solving the problem, the future problem about the thermal challenge and things, there's also a thermal challenge at the edge as well. Think about if we don't have enough air conditioning and others to cool down the machine, and how we are going to solve that. We also invest a lot of resources to make the edge AI possible. So this is the two things that we want to make sure when the chance is coming with the AI computing through the different platforms, we always want to make sure this machine will be able, good for the good return of investment for the next few years. Once you deploy the device at the edge, you don't want to change it every year. So the liabilities and also the mean time between failure, those numbers are all we care. And that means that you need to have a very good component experiences and knowledge to protect those investments. And which is the reason why I mentioned about the average selling price per machine now. It's actually pretty high selling dollars. And it's also create a big pressure for those people who's going to acquire it, use it, and protect it. So we would like to put more efforts to make those machines reliable and also can continue last longer as they expected. So that's our plan for now.
Thank you. Thank you, Mory. So, like these days, we see the climate change and the global warming, and we see like industry have a lot of effort to reduce the power and make it more sustainable for our next generation. A very important topic. And so the next question we're going to Jack. I'm not sure if people know SiFive is a RISC-V based company, and Jack is the number 6 employee of that company. Then always wondering for the SiFive, they are ready to take a market share from ARM and x86. I'm wondering, how do you see the inventor of a RISC-V, which actually founded SiFive, and SiFive has been a leader in the RISC-V space. Can you explain how do you see the importance of a RISC-V in the AI market?
Yeah, that's a very good question. So I guess I'm curious, how many people know what RISC-V is? Okay, so we're making progress, I guess. So So, if you're not in semiconductors or chip, maybe it's a little bit difficult. But let me explain a little bit really quick what RISC-V is, because then it'll lead into why I think it's very important for new technologies like AI. So RISC-V fundamentally is what's called an instruction set architecture, or ISA. And the world today, before RISC-V showed up, really had two ISAs. There was x86, which had two companies, Intel and AMD, were the only companies you can get x86 for, and you can only get it by buying their chips. And then there was ARM. Now, ARM, it seemed like you can buy ARM chips from everybody, but there was only one company that would provide the underlying technology, the CPU, and that company was called ARM. They just went IPO this week. Congratulations to them, $60 billion. But the world only had these two choices until RISC-V came around. And RISC-V is different than ARM and x86 in that RISC-V is an open standard. So if we look inside our industry, our hardware industry, pretty much everything other than CPU ISAs is an open standard. Think Ethernet or Wi-Fi or even 5G. These are all standards that anybody can implement and compete with. Only in the case of the ISA, somehow, did we end up in a situation where there was two proprietary standards. Now, one of the reasons why this is so important is because the ISA defines how the hardware talks to the software. So how does all the software get written, the software ecosystem, the thing that is actually the biggest investment that everybody has to do, even though we're all hardware guys, it's like actually the software part is the part that's really hard to change. The software investment has to go against the ISA. So Windows was written against x86, so we had Wintel for the longest time. And now there's some Windows on ARM stuff, for example. Android is on ARM, that's why they're very strong in mobile. So similar type of things. So RISC-V and SiFive, were founded by the inventors of RISC-V. So, when I say made progress, when we started, we had to explain why this was even important. And the more anybody knew about CPUs, the faster they ran away. Because, why? There is no new ISA. It's been 30 years. Every 30 years, one comes along. But so when you look at new markets, new technology areas where a lot of new software is being written, it's actually very ideal for RISC-V because you have to write a lot of new software anyway. So if you're starting off on a blank sheet of paper and you say, I'm going to write a whole bunch of software for x86, so I'm going to lock myself into these two vendors, or I'm going to write a whole bunch of software for ARM, which means you're basically dependent on what one company will provide, or will I go to do it with RISC-V? So if there's no existing software, the choice is actually very easy. If there's existing software, you have a more difficult decision. So we look at something like AI, and because it's evolving so rapidly and so quickly, people are able to say, what do I want to do here? And they're looking at new things. So RISC-V has a very important role to play because the software is new. So how do you adapt that technology into it? The other major benefit that RISC-V provides compared to the others, as I mentioned earlier, it's an open standard. So of course, SiFive, we provide RISC-V solutions, but you can build your own RISC-V. Other people can build their own. We have competition. And this means that you can customize the RISC-V implementation. You can extend it, you can configure it, you can do all sorts of different things that you just simply cannot do, right? So like if you want to do something with ARM, you have to go ask ARM, and if they say no, then that's it. It's a no. If you want to do something with RISC-V, even if SiFive says no, you can find somebody else who will say yes, or you'll do it yourself. So what this means ultimately is, just like with every other standard in our industry, you come in with competition, you have more choice, the best solutions will win, but it also means you'll have the largest number of RISC-V implementations, the biggest diversity of RISC-V implementations, because now people can compete and they can go into different niches as appropriate, but leveraging all the same software. So what RISC-V brings to AI is the ability to make your hardware engines very programmable. So you need the hardware, the CPU, you have all the common tool chain, the software, the compilers, the libraries, and then you can attach your accelerators to the RISC-V core. And then you can connect that to a large decision-making RISC-V core. If you look at NVIDIA's architecture, they have Grace and Hopper, right? Grace Hopper. Grace is just a big CPU feeding data, making decisions. Hopper is just a big GPU accelerating the AI portion. So what I just described is you can use RISC-V connected to accelerators or by itself to do all the acceleration. And then you can still have large RISC-V cores to do the compute and decision-making and planning. And now because it's all RISC-V, you can imagine the software capabilities that come from this, because now you can virtualize across these cores, you can share workloads, you can pass things along much better. So this is where people look at, oh, I'm going to write new software, what new things can I do? And then RISC-V is so attractive for that.
Thank you, Jack. So now we see, like in this generation, all the computing we have to design from bottom up again, like back to the early time of x86. A lot of player, everything have to be reconsidered for some of the AI hardware, software perspective. Now I have a question for Williams. So when we're talking about all the hardware size, I'm wondering, what do you think? In what kind of role of the software is playing in today's to maximizing the capacity of today's AI hardware? Can you share something on that question?
Sure, yeah. Part of that is an extension of what Jack mentioned, right? So in the AI space, interesting enough, especially in the inference world, right? Not so much in the high-end training, but in the inference, dealing with, like the edge servers from Mory's company, from, wearables that you may have in your pocket. In the inference world, on one end, you have AI scientists developing different kind of neural network models on different platforms, such as Onyx, TensorFlow, TFLite, etc. On the other end of that, you have, right, of course, the different kind of hardware, whether it's a CPU, an NPU, or it could be even DSP. That could be all in the SoC, or system on the chip. So the AI scientists, when they develop the neural network models, the new neural network models, they may not know eventually what kind of hardware is going to process their models. On the flip side of that, people like all of us sitting here on the stage, we don't know tomorrow what kind of a new models and new layers and operators we will be dealing with. So this is where it is critical for a robust, sophisticated system-level software to bridge the gap, right? So a sophisticated system-level software, on one hand, they need to understand most, if not all, of the models out there, right? They had to build their model zoo, right? On the other hand, when they, look at a unique customer situation where they have an SoC, the SoC may have CPU, NPU, even DSP, and different kind of memory configuration, they say, okay, so how do I best optimize, how do I make this AI processing most effective for a given model by taking advantage of the hardware that's available? That's an easy say than done. You look at you have to manage the different hardware. You have to make sure which piece of hardware is going to use how much of the memory, and as you distribute different tasks, like for example, if you're really into AI, there's such, you probably heard of NMS, which is non-maximum sorting. That's best handled by CPU, like from the ones from SiFive. And there are other parallel processing that can be done in NPU. So it is really a pretty interesting and challenging task for the software. So in that regard, the software play a very important role in all this. Since we are in this is TTS, Taiwan Tech. So there's actually a software company in Taiwan that's doing a very good job with that, and that company is called SkyMiser. So that's.
Thank you. Thank you, William. Thank you for sharing that. So in the Taiwan Tech Summit, it's very impressed that we have people from all the different areas. Then that's somehow make it some topic choice a little bit harder. And I think all the panelists, they explain it very clear, try to make it, especially in hardware, much harder than software. So these days, that's why NVIDIA much higher market cap today. Okay, so I have a question back to Mory. So last time, in the last question, Mory shared with us how SuperMicro was managing the very high thermal power issue. We know that's not the only secret something they do in that area. We want to ask Mory, what other things SuperMicro do to optimizing their server hardware for this unique requirement for the GPU accelerated or accelerated computing for those AI workloads? Do you have something a little bit more to share with us?
Yeah, so I probably need to answer this question carefully because I think for all the hardware companies, when we start to announce the features, for sure soon the competition will come after right away. But we also believe in that this will encourage us to run faster. So definitely I answer these questions about after those performance thermal challenged. What else we are going to help this AI possible in the different angles. And I really appreciate Jack and William mentioned about openness and also the AI things. Actually, indeed, we are not able to control the future of the AI, but we do have a chance to contribute how to make the AI become affordable to different level of the applications. And to reach this level, we have to think out of the box. If we continue solve the high-end GPU and high-end computing inside data center, there will be just one big perspective of the world who need the AI for those ChatGPT big topic, large language modeling things. But what about those peoples? They need the AI power to drive the different applications at the edge. And I want to elaborate this topic a little bit more. For instance, like we have a certain application, I recognize two presenters mentioning about the inferencing. So I have some real maybe experience to share with you what's happening right now at the field. Imagine you have to find lots of money to buy the big machines in the data center to host everything by yourself. There must be a group of people just need a certain computing AI power for a certain period, not forever. You have to only for a whole year. For instance, like scientists, they finish their study, they finish their modeling, but they need someone to prove what they are thinking are the truth. Like what you are doing right now, you want to make sure your autonomous algorithm will avoid to create casualties. Those things just in your mind, in your programs, in your proposal, but you need someone to prove it as one of the supporting factors, not necessarily the fact after the field test. So there are certain people who start to think about how to lease those GPU power to the customers. And those people are thinking about how to make sure those data center closer to the edge. So after this topic, I'll talk about the edge AI part. So that means it's no longer just talk about the data center high density level. It's also become a modularized. The data center have to closer to the specific country, specific locations. And second thing was about the data breach issues for the security topics. Lots of people have a concern about put everything in the cloud because they might have knowledge to protect everything. What about your AI power and modelings? So there are many topics will be involved how to make the hardware become more secure before they onboarding everything on top of that. So those are the things SuperMicro keep investing a lot, not just from hardware thermal perspective. We actually want to make sure our devices will be secure enough before you load everything into it to run your modelings. And after this too, data center, edge data center, and there's a topic coming in like edge inferencing devices. We use the same concept. We just brought that kind of a concept to help the edge application. In that level, there are different level of the challenge coming back. They no longer just ask us to make it modularized. They just want to make sure it's cost effective, affordable. And then some of the machine, they just need inferencing. So they don't need so many machine learning power. From that perspective, I think the different CPU technology will bring the different openness, and programmable is the key. Because if you cannot do this job right, how can you believe your data center computing algorithm will be okay at the edge machines? It will crash. So that's the reason why flexible, programmable is the key openness as well, not just in the past few architectures. It's actually also impact the AI modelings. And we are the expert on the hardware level, and we also listening carefully. So that's why we not just invest in the data center at the edge from hardware. We also recognize the next step is how to protect those apps and how to make sure those apps will have enough computing power through CPU, through GPU, through others. So they will be the continuous topic in the next few rounds. And we hope we can make sure we can always in the leading position to help the world. Thanks.
Thank you, Mory. So that's a very different consideration between AI workload or AI specific design in the data center and edge. Like what Mory pointed out, in the edge will be no like a security, powers, all those still is very different perspective. Now I have a question go to Jack. So along the line, we see SiFive, the RISC-V based company. Can you share with us what kind of a role SiFive did in shaping an AI-specific extension to the RISC-V architecture, which is originally only based on general computing, now go to the AI age, it's become very different.
Yeah, so earlier I mentioned one of the nice things about RISC-V is that it's designed for customization and extensibility and things like that. Because it's new, a lot of the things that are being added to RISC-V, the standard as it evolves, there's opportunity to add in specific things. For example, one of the main parts of the RISC-V ISA is called the RISC-V vectors, or RVV. So vectors is just a way to compute lots of data very, very efficiently. But vectors is built in to the RISC-V standard in the ISA because it's coming up right now in a time of obviously AI and need. So one of the things that happens is for RISC-V vectors, for example, and other things is like what kind of data types do you support? So there's like native support for like bfloat 16 and other things that have just come in from AI that hasn't really made its way into general purpose computing, if you will. So once it goes in, then it's part of the RISC-V standard. And now you can talk about things earlier when I said that, the compilers and the libraries and the tool chains all know how to speak that, all know how to generate software for that thing. And because RISC-V is extensible, because RISC-V is a standard, right? So you can imagine that there can be a RISC-V implementation that's a very large CPU, very high performance, 32 core, 64 core, 128 core type cluster CPU that runs RISC-V, and it can scale all the way to the edge. We have customers who use our core, they run it on like AA battery powered devices. And these are the same ISA, so you can run the same software, so everything in between. And because it's all RISC-V, as software gets developed for one segment, it can be adopted and used by the other segment. Right? So this is the benefit and the power of the ecosystem. And this is the benefit of the power when lots of people come in together into an open standard. So where SiFive, where we have a specific role is, first because we invented RISC-V and we're the leaders in RISC-V, a lot of the new development customers work with us. And then a lot of the standards that are being driven, we contribute significantly to those standards, where we contribute the standards back to what's called RISC-V International, which is a standards body that's managing the RISC-V standard. So just as an example, earlier this year, we donated the security standard back to RISC-V International. So everybody who's using RISC-V has the same kind of architecture for security, right? Not directly related to AI, but very related to our deployments, as you just mentioned. So you need to have all these additional components that are brought in. And I think RISC-V is kind of a unifying way to do that. And then you have the very specific implementations from small to large and medium and everything in between. And that's where you're going to have lots of opportunities, not just for SiFive, for us to service our customers, but also for competition to develop their RISC-V solutions as well. So at the same time, we're growing the entire RISC-V ecosystem. We're also competing within it.
Thank you, Jack. That's very insightful. As we see, the AI was involving all those areas that's got a lot of work need to be done. And William, from their edge or low power device consideration, I want to ask William, can you help us to understand or can you describe how the AI inferencing IP, they, especially in the edge and those areas, they need to design to work seamlessly with so many various applications. Can you help us to understand that a little bit better, for the, especially in that IP area?
Sure. So to understand how a particular AI architecture, such as the one from the company I'm with, Expedera, can handle from very low-end application. Like I have a customer who's doing Bluetooth headset. They are not talking about watts, they're not talking about milliwatts, they're talking about microwatts, right? So from there to something like autonomous driving, I'm talking about not level 2 plus, but level 2, 3, or 4 kind of autonomous driving, or even inferencing in the data center. So if you want to have one architecture covering all of that, right? And I know Jack mentioned that as well. It would be interesting to focus on what's the most challenging aspect of AI, right? It is about data, big data, a lot of data, right? So in the hardware, from the hardware perspective, AI processing takes a lot of memory, whether it's SRAM, DRAM, HBM. And the reason it requires a humongous amount of memory is because if you look at a different neural network model, you know, it doesn't have to be LLM or GPT, right? If you look at a CNN, you know, convolution layer, it takes just a lot of, you know, the weights and the activation. You know, traditionally, the CPU, GPU, or NPU, they download one layer at a time down to the memory. And so you need a big chunk of SRAM inside the IP or inside the SoC to accommodate all that. That, of course, takes a lot of space in terms of die area, and which translates into high power, and not to mention low utilization, because once the data is in the memory, you need to do pre-processing. You need to reduce the graph of that particular layer down to each individual instruction and feed it one at a time to the whatever processor you are working with. So a lot of time, regardless of what hardware you are working with, that processor is actually idling. So how do you address that kind of challenge? Well, one way to do it is to packetize each layer, right? Instead of a big chunk of layer, you break it down to a smaller unit, like, we call packets. And so by doing that, your memory requirement can be reduced significantly. And that translates to lower power, smaller die area, and just as importantly, I mentioned about utilization. When you have a smaller packets, you can feed those smaller unit of data to your NPU so that your NPU will be busy most of the time. So your utilization goes up tremendously. So that's so that is how, please consider this as a case study, not a sales pitch. So this is just one way to solve that problem. But by using that kind of unique architecture, the Expedera solution can address low power, like I mentioned, a Bluetooth headset or something similar to that on one end. By using the same architecture, we can address high performance applications like autonomous driving or even inference in the cloud, where you start talking about hundreds of TOPS, as teraops per second. So yeah, that's one case study where one architecture can address low power to high performance all at once.
Thank you, Williams. Because of the time, I have one question, one last question I'm going to ask, but help us to understand. So we know previously we have a cryptocurrency, we have a metaverse. I want to ask our panel from there, they have a great experience on all those areas. What do you see this tide of the AI wave? Do you think it's real or is a hype? Can you, a few sentences, can you help explain to understand? We'll start with Mory.
First of all, I think it's hard to comment on that question directly, but we just maybe share the experience and also why we are doing this to support some directions. First of all, I think we invest a lot already to help the AI to run, and then it's not for specific workload. And we talk about several hardwares. I know it's very tough in just one mornings to ask you to remember so many things, but let's just forget about what I present this morning about hardware. Let's just look at some cases I can share. We do have a customer use those AI to do lots of things, not about those two applications Mark mentioned. And those are cross-industry. So first of all, like those people need ChatGPT, but not allowed to use the public ChatGPT. The consulting firms, those people have a lot of business case on hand. They hesitate to move all their data to the ChatGPT, but they want to make their consultant run like a super smart guy. So how to solve that problems? So they have to build their own ChatGPT in the places they trust. So that's industry you can think about. As long as they have to provide you the special service for consultancy, then they need the AI to help them to make their team and people work faster to give you more precise predictions or recommendations. So it's a mix. With the machine's help, still give you the real person services to help you reach the goal. There's just one angle. But we also have a situation in the autonomous industry, as you all know about that. Lots of the autonomous driving topics, they need to study the pattern of data they collect. And there's a big question is how much trust you believe in that. So someone have to keep proof, not just about the result, also need to make sure it's will be a real one can run at the field. And those one also need lots of the GPU AI powers. And no longer just limited to this two, we actually have more customers that are coming back asking for a solution to solve their problems. And so from those kind of different vertical market observation and SuperMicro's existing customers, we recognize they are not here to talk about dreams. They are not here to talk about concepts. They actually have to make their existing business run faster to, either keep their leading positions or totally try to kill the other leaders' positions. So AI has kind of become very luxury machines for them to change their market position. And because of this, I think we don't know how long it will last about this AI topic, but we definitely know as long as those services need to be upgraded to a different format, it must be someone have to empower behind, just like the computing in the past. Now AI is going to do this for AI for everything. And our job is to make it become a very friendly accelerator to all the application. So from the angles, I think our investment or our observation will help you to build your own observation and perspective.
Thank you,
Thanks,
Mory. How about Jack?
Yeah, I think I think my private company, so I can be a little bit more open. he cannot say that AI sucks. He'll be in trouble. So I think the most important thing everybody should take away is, to me, AI is a technology. It's not a product. It's not a vertical. If somebody tells you I have an AI chip, your next question should be like, for what? Like, what does that chip do? Because otherwise you can call everything AI. Now, AI is forcing everybody to build more compute. So that's great. More compute, good for all those hardware guys. That's definitely true. But so it's not a hype cycle, but AI is a technology. It's how are you going to apply this broad set of technology to solve specific problems? And I think right now, even AI, really, there's only been like one killer use case, which is ChatGPT, sort of, and maybe autonomous driving, maybe. But what is it actually solving? So maybe I'm downplaying a little bit, but I think, the key is like, what is AI actually solving, and how does it apply? It's a technology that will apply to many different verticals. It by itself is not a vertical.
Thank you, Jack. Williams.
Yeah, so so I totally agree. AI is not it's a technology, it's a solution, it's not a product. From marketing point of view, AI is a very powerful marketing acronym. There was a study recently that, for those of you who are in investment, the companies that mention AI in their quarterly report as a group, their stock gone up quite a bit more than those who didn't mention AI, right? So I can, but get back to your question. I can think of a couple examples. Now, AI is, may be relevant in some area, but not so much in other. But how about, say, agriculture, farming, right? So I run into companies and customers that they actually apply AI in the farming space. Famous farming equipment companies that actually use AI. For example, they use a drone to look, the farm and direct the machines on the ground to, as far as determining how much you fertilize and where and that kind of stuff. The other example is I was in another panel discussion just a few weeks ago where the chairperson and the professor, Dr. Pan from UT Austin, he specialized in, so we are talking about how to use hardware to solve AI, use AI to solve different problems. He's talking about using AI to design chips, especially for those of you who are in the back-end design, doing place and route. It is rocket science to figure out how to, squeeze as many transistors as possible, but still be able to route the wires without getting to antenna and crosstalk kind of problems. So yeah, I totally see AI will take us, there's just no limit.
Thank you.
I forgot there are investors here. AI is great. Just invest in AI. It's good. Vertical market, no problem.
Thank you. So thank you for all the panelists for sharing their great insight and time with us. Let's give them another applause. And they will conclude today's AI Hardware Forum. Thank you.